Timeless Concepts from Physics Helpline. This is a video tutorial series through which we will sharpen our problem solving skill. In this video tutorial, we will discuss a multiple choice question with only one correct option on the determination of Planck's constant from photoelectric effect. The question is as follows. In a historical experiment to determine Planck's constant, a metal surface was irradiated by light of different wavelengths. The emitted photoelectron energies were measured by applying a stopping potential. The relevant data for the wavelength lambda of incident light and the corresponding stopping potentials vDo are given below. For lambda is equal to 0.3 micrometer, 0.4 micrometer and 0.5 micrometer, the corresponding values of vDo are 2.0 volts, 1.0 volt and 0.4 volt respectively. Given that velocity of light c is equal to 3 into 10 to the power 8 meters per second and electronic charge E is equal to 1.6 into 10 to the power minus 19 coulombs. Planck's constant in units of joule second found from such an experiment is. The options are 6.0 into 10 to the power minus 34, 6.4 into 10 to the power minus 34, 6.6 into 10 to the power minus 34 and 6.8 into 10 to the power minus 34. Now for the answer. From Einstein's photoelectric equation, we get the following. When light of wavelength lambda is incident on a metal surface having work function phi, then the maximum kinetic energy of the ejected photoelectrons is given by half m v max square is equal to hc by lambda minus phi. If the stopping potential is v0, then half m v max square is equal to EV0. Therefore, from equations 1 and 2, we get hc by lambda minus phi is equal to EV0. Now, for lambda is equal to lambda 1 and v0 is equal to v1, we have hc by lambda 1 minus phi is equal to EV1. For lambda is equal to lambda 2 and v0 is equal to v2, we have hc by lambda 2 minus phi is equal to EV2. And for lambda is equal to lambda 3 and v0 is equal to v3, we have hc by lambda 3 minus phi is equal to EV3. Subtracting equation 5 from 4, we get hc into 1 by lambda 1 minus 1 by lambda 2 is equal to E into V1 minus V2. It is given that C is equal to 3 into 10 to the power 8 meters per second, E is equal to 1.6 into 10 to the power minus 19 coulombs, lambda 1 is equal to 3 into 10 to the power minus 7 meters, lambda 2 is equal to 4 into 10 to the power minus 7 meters, V1 is equal to 2 volts and V2 is equal to 1 volt. Therefore, equation 7 gives H into 3 into 10 to the power 8 whole into 1 by 3 into 10 to the power minus 7 minus 1 by 4 into 10 to the power minus 7 is equal to 1.6 into 10 to the power minus 19 into 2 minus 1. Which implies H into 3 into 10 to the power 15 into 1 by 3 minus 1 by 4 is equal to 1.6 into 10 to the power minus 19, which implies H into 3 into 10 to the power 15 into 1 by 12 is equal to 1.6 into 10 to the power minus 19, which implies H into 10 to the power 15 into 1 by 4 is equal to 1.6 into 10 to the power minus 19, which gives H is equal to 6.4 into 10 to the power minus 34 joule second, which is the answer to the question. Therefore, the correct option is B. It may be noted that we have used equations 4 and 5 to obtain the value of H. We can also use equations 4 and 6 or equations 5 and 6 to obtain the value of H. This completes the answer to the question. Thanks for watching. If the video is helpful, then please like, share and subscribe.